On to Chapter 9. So Chapter 9 deals with, first off, sequences. So a sequence. So you'd have this one be an example of a circuit sequence. In this case, this one is the Fibonacci sequence. So in terms of representing it with a sequence, we can first have in terms of what would be called an example of an explicit formula. So I have with something like this, that a sub n is equal to 3 times n plus 2. And so a sub 1 would be 3 times 1 plus 2, which would be 5. A sub 2 would be 3 times 2 plus 2, which would be 8. And we could keep on going and going and going. Well, the other type of way of writing a formula is called a recursion formula. So now you would have something that looks like this. So I would tell you, let's have the first term is some number, so let's do 4. And then the next term, a sub n, is 2 times the previous term plus 5, right? So we know a sub 1 equals 4. So that would mean that a sub 2 is going to be 2 times the first term plus 5, and that'll give me 13. And so then the third term is going to be 2 times the second term plus 5, and that will give me 31. So it'll be an example of that. Okay? Okay. So if the sequence converges, it will have a limit. Now then we can have infinite series. So given a sequence, so a sub 1, a sub 2, a sub 3, a sub 4, so on, so on, and so on. Right? And so a sub 1 plus a sub 2 plus a sub 3 plus, right, is going to equal the sum of the terms k equals 1 to infinity of a sub k. So we can look at the sequence of partial sums. So s sub 1 would just be the first term. S sub 2 is the first plus the second. And then S sub 3 is the first plus the second plus the third, and so on, right? So if the sequence of partial sums converges, then the infinite series converges. And of course, then the other side, if the sequence of partial sums diverges, then the infinite series diverges. So let's look at an example. So let's say I had this one. K equals 1 to infinity, 1 over K times K plus 1. So let's get some terms here. So let's see. So let's see. A sub 1, term 1, A1, is going to be 1 over 1 times 1 plus 1. And that'll be 1 half. A sub 2 is 1 over 2 times 2 plus 1. And that'll give me 1 over 6. A sub 3 is 1 over 3 times 3 plus 1. And that'll give me 1/12. And then A sub 4 is 1 over 4 times 4 plus 1. And that'll give me 1 over 20. Right? So we got our terms. Now let's look and see what's going on with our sums. So S sub 1 is equal to 1 half. S sub 2 is 1 half plus 1 over 6, which is going to be 2/3. S sub 3 is 1 half plus 1/6 plus 1/12, and that is going to give us 3/4. And S sub 4, 1 half, 1/6, 1/12, 1 over 20, and we end up at 4/5. So it looks like we are converging. And it looks like that the limit here, as n goes to infinity, of S sub n is going to be 1. So let's say we now have in terms of this sequence here. And so we have A sub n is n to the 3/2 over n to the 3/2 plus 1. So A sub n is positive and increasing. Right? So the limit as n goes to infinity of A sub n is going to be the limit n goes to infinity, n to the 3/2 over n to the 3/2 plus 1. Right? And so now if we take everything and we divide by n to the 3/2, this will give us 1 over 1 plus 1 over n to the 3/2, and 1 over n to the 3/2 goes to 0. Okay? And so this is going to be 1 over 1. And so we end up with an answer of 1. Other type of sequences, we had geometric. So a geometric sequence was then something like this: 0.75 to the n, 1.15 to the n, and so on. Okay. So let R be a real number. So then the limit as n goes to infinity of R to the n will be 0 if the absolute value of r is less than 1. It is going to be 1 if r is equal to 1. And does not exist if r is less than or equal to -1 or r is greater than 1. Right? And a few other terms here. If r is greater than 0, r sub n is a monotonic sequence. Right? And if r is less than 0, then r to the n oscillates. So really what that means is that sometimes the answer is going to be positive and sometimes the answer is going to be negative. Right? And then a bounded monotonic sequence converges. All right. So how about this one? What is the limit as n goes to infinity, n cubed over n to the 4th plus 1, right? So again, if we divide everything by n cubed, and if we do that, we're going to get 1 over n plus 1 over n cubed, right? And of course then 1 over n cubed is going to 0. And so this will just be 1 over n, but n is going towards infinity, and so we end up with an answer of 0. And if I had 0.2 to the n, right? So the absolute value of r is less than 1, and so 0.2, the absolute value is 0.2, and so that is indeed less than 1. And so the limit as n goes to infinity of 0.2 to the n will be 0. And that would be a monotonic sequence. Let's see. Infinite series. And geometric series. So a does not equal 0, and r is a real number. So if the absolute value of r is less than 1, then k equals 0 to infinity, a times r to the k is going to equal a over 1 minus r. Right? If the absolute value of r is greater than or equal to 1, then the series diverges. So here it converges, and then so let's do an example here. So let's say we have this. k equals 0 to infinity, 1/4 to the k. Right? And so r is going to be 1/4. So we have 1 over 1 minus 1/4. So this is going to be 1 over 3/4, which would then equal 4/3. They also talk about in terms of those repeating decimals, so like 0.3 repeating, which would be 0.3333 plus, or not plus, but dots. Okay. Dot, dot, dot. So I could rewrite this as 0 plus 0.3 plus 0.03 plus 0.003 plus so on, so on, so on. And so A would be equal to 0.3. R is equal to 0.1. And so we get 0 plus 0.3 over 1 minus 0.1. And so this is going to be 0.3 over 0.9, which would be, of course, 1/3. And so 0.3 repeating equals k equals 1 to infinity, 3 times 0.1 to the k, which will be 1/3. And then the chapter talks about some various tests. So we have here in terms of divergence test. So if the sum of a sub k converges, then the limit as k goes to infinity of a to the k is going to equal 0. And I should redo this. Okay. And then if the limit as k goes to infinity of a sub k is not equal to 0, then the series diverges. Other types of series, harmonic series. And so something looks like this. K equals 1 to infinity, 1 over k. So this would be 1 plus 1/2 plus 1/3 plus 1/4 plus dot, dot, dot. Okay. Diverges, even though the terms of the series approaches 0. just need to check one thing. Make sure I got that K in the right spot. So let me just go back. So I just want to make sure I got my K's in the right spot on that one. All right. So let's see. So chapter 9. A sub K. Yep, okay, I was right. I had it right the first time. I thought so. Okay. Let's just put that right down there. All right. FK, and again, same thing here. Come on, eraser. Yep. All right. There we go. If sum of A sub K converges, then A sub K, yep. Alright, got all my K's in the wrong spot. So let's get those out in the correct spot. There we go. Now we're better. Okay. Got that. Got that correct. Okay. Alright. 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 So let's go on. Next one then is what is the interval text. So let's say f is continuous. Positive decreasing function. For x greater than or equal to 1, then let a sub k equal f of k for k equal 1, 2, 3. Right? Then k equals 1 to infinity, a sub k, and the interval of f of x dx it will either both converge or both diverge. So let's look at one. So let's do this interval text. So yeah, k equals 1 to infinity, k over k squared plus 1. So that would mean f of x is going to be x over x squared plus 1. Okay. And we can look at some of the terms here, and so I can sort of start plugging in. So if I plug in 1, this is going to be 1/2. And then we're going to get 2/5. And then we get 3 over 10. And then we get 4 over 17. So yes, the terms are positive and they are decreasing. Okay. So then the interval of 1 to b of x over x squared plus 1. Okay. And so let u equal x squared plus 1. And then du is going to be 2x. Right. And so now we get, this is going to be the interval 1 to b of du over u. And so, and then my factor here is going to be 1/2. Right? And so we get 1/2. And then if I integrate this, it'll be natural log of u evaluated from 1 to b. And so this will be 1/2 the natural log of x squared plus 1 from 1 to b. And so this will be 1/2 times the natural log of b squared plus 1 minus the natural log of 1 squared plus 1. And so there'll be 1/2 natural log of b squared plus 1 minus the natural log of 2. And now the natural log of b squared plus 1, well, this number is going to be getting larger and larger. So this one diverges. So the series diverges. And then lastly, we leave off with things called a p-series. And so a p-series is something that is in this form. So 1 over k to the p. Right? And so we have this, and so where p is a real number, right? And so this is going to converge for p greater than 1, and it will diverge if p for p less than or equal to 1. So if we had something like this, and I went, okay, does this converge or diverge? K equals 1 to infinity, 1 over k to the 10th. Well, p is equal to 10, and so this converges. Right? And that will conclude this video.